Today we're going to finish up section 12.2, and this will be the end of the notes for the year. You can use a date of May 15th. If you'll take a minute and read the scenario for our last example. So we're going to compare two different types of materials used to repair serious wounds. We're going to compare the extracellular material that they're going to abbreviate with ECM and the inert material that they'll abbreviate with MAT. So, is there going to be a difference between the two when repairing the wounds? We're going to start by looking at the data. If you want to pause the video for a minute and enter the data into your iPad, we want to make a table with the sample size, the mean, and the standard deviation for each of our 6 different groups. So here's a summary of all of our sample sizes, our sample means, and our sample standard deviations. So they want to know, is it reasonable to pool the variances? We can see that we do have one that's significantly different than the rest, and the rest are actually all the same. But remember, the test says if you take the smallest standard deviation and square it, and it's still less than the largest, then it's safe to pool. And that is in fact the case here. So we will use a pooled standard deviation. So let's run our ANOVA. So go ahead and do that on your iPad, and then we'll come up with a statistic to determine if there is a difference between the two different types of materials. So remember, for degrees of freedom, we have 6 different groups, so it's going to be I minus 1. The total observations is 18, so the total is N minus 1, and that will leave us 12 degrees of freedom for the error. The sum of the squares is also provided on the iPad. I did add the total in. We'll fill in our mean squares. And then all of this can be done by hand, but we have our F statistic, and that's pretty large. So our p-value is 0. And at this point, I did record the pooled standard deviation so that we can move forward. So we know that there's a difference between the two types of materials. Thinking that you weren't aware of this before you ran your test, we would not have been able to set up a contrast. So we're going to try a different method today. We can use Bonferroni, but we need to know the p-values for these. What we're going to do is the multiple comparison pairwise tests, the t-tests, to determine which pairs of means are different. This is a very tedious process. I know I didn't leave you enough room in the packet, so it's up to you. You can either write down the results for each of these 15 pairs. I do go through all the calculations. Some of you might want to just do it on a separate sheet of paper and attach it to your packet. We're going to start with the top row, these 3 different pairwise t-tests. So the formula on your card says we're going to subtract the means. I did leave these in the order that they're described. So you have extracellular 1 versus extracellular 2. We have a pooled standard deviation. This will be the same value throughout all 15 tests. And then underneath the square root radical, it's 1 over the sample size for E1 and 1 over the sample size for E2. But in all of these cases, this entire denominator will be the same because there's 3 samples of each type. All right, as I go through the test, I have a t-statistic that's positive. These are all 2-sided tests. So because this is positive, when we calculate p, it's a 1 minus, and then we're going to multiply by 2. So I didn't show all those steps, but ultimately I can see that there is no significant difference between these 2 materials based on my p-value. I'm going to go ahead and do this for E1 and E3. I'm changing my X bars out. Denominator stays the same. Now I have a negative t-statistic. That means I'm in the left-hand side of the distribution. So the p-value that I do get, I'm just going to multiply by 2. And again, this one does not show statistical significance if we use alpha set at 0.05. Let's go on with our third test. Changing the numerator. Now my t-statistic is pretty high, so when I put that into the calculator, essentially I get a 1, but it's really a 1 minus because we're on the right-hand side of the distribution, so my p-value is 0. So this is the first instance where I get a value that is significant. But if you'll notice, we did compare the extracellular to the inert material. We're going to continue to do this for all remaining 12 pairs. So I won't talk you through it, but I will bring up examples if you want to pause the video so that you can do it yourself before they're revealed. And if you find any mistakes, just let me know. So this comparison does come up significant. And this one comes up significant as well. You'll notice they're both comparing the extracellular to the inert. This one is significant. If we set alpha at 0.05, here's another case where it's significant, comparing extracellular to inert. Another significant test. And another significant test. All three of these were extracellular versus inert. So already you're getting the idea that we do know that there's a difference between the two types of materials. We'll keep testing. This is why setting up a contrast in advance is so important. The pairwise t-tests are doable. They're just tedious. There's another significant test. And another significant test. All three of these compared extracellular to inert, so there's a difference. This test is significant when you're comparing the two inert. There's one is significant as well. This one is not significant. So I think what we can pull from that, all the values that showed a significant level of evidence against the null, all compared an inert material and an extracellular, but that is a tedious process. So prior to doing this experiment, I think you would have known that there was a difference between them. You can really see it in the data. So I would have tried to design a contrast. So for the last little bit, we're going to do a contrast to compare our 3 extracellular materials versus our 3 inert materials. So we're setting up psi. I'm using positive 1s for the 3 extracellular materials and negative 1s for the 3 inert materials. Remember, the coefficients can be reversed as long as they sum to 0. So starting with the value of the contrast, I'm going to sub in all my x bars. Make sure you're plugging in extracellular for 1, 2, and 3, and inert for 4, 5, and 6. I'm trying to use the order they did describe in the table. And my contrast value is quite large. Now we need the standard error for the contrast. So we're using our pooled standard deviation obtained from our iPad. All the sample sizes are 3. If they weren't all 3, each of these denominators would be different and it would be dependent on that particular sample size. And in the numerators, I have my 3 positive coefficients and my 3 negative coefficients. So if you plug all that into the iPad, we have a standard error of 6.2361. Moving forward, so essentially we're testing that psi is either 0 or it's not. I'm going to sub in the contrast value and the standard error. And I do have a large t statistic. Remember, we're doing a t-CDF on the calculator. I'm using my upper bound that I've just calculated, and we have 12 degrees of freedom. This is the degrees of freedom for the error. And I do get a 1, and because t is positive, we are in the right side of the distribution, so it's a 1 minus, and essentially p is 0. So we can conclude at alpha that the means for the extracellular material and the inert materials are different. Our last problem of the year is going to be 12.46. You can omit part F, and if there's any data for me to send, I will be sending it to you in an email. Have a great day.